Okay, looks like everyone's in the room now. Woohoo. Some housekeeping, if anybody does need to leave because my talk's shit, please crawl up there so you don't block the screen. Hello everybody and welcome to my nuclear demo. The title isn't quite right. The first half of the presentation will be about OT, critical national infrastructure and things like that. The second half will be a live, very quotes, hack, which I filmed it live, so it happened live once, but no, I'm not typing it on here after some of the disasters I saw today. So, this is me. My name is Nathan Pooley. I'm an OT cybersecurity consultant at Airbus Protect, depending on which customer you speak to. I'm a senior OT cybersecurity Protect. I was a previous check team member in infrastructure. I am part of the NCSC I-100, which is Airbus is a part of. You'll learn a bit more about that later. I specialise in CNI, critical national infrastructure, nuclear and water, and I was a former yobbo. I'm from Salford, and to do anything like this, it was more like on construction sites, stealing shit, but here I am, turned it all around. I actually went to this uni, and some of my lecturers are sat at the back there. Rod Douglas, who there, stand in the air. Give him a big woo for Rod, yeah, good job, Rod. Taught me everything I know, so here we are. So, this topic, the talk objectives are an overview on operational technology. Everyone's heard of IT, not really heard of OT. IT versus OT, standard and reference models related to OT, things I've never heard of before I went into OT. CNI, what it is, how it works, how you often interact with it, and career paths into OT, in case any of you think, oh, it's dead cool. So, you're also going to see that live hack on screen, and I also have to plug the Airbus product because my boss said so. Okay, IT. I take everyone in this room knows exactly what IT is. Emails, help desk, cybersecurity, backups, anti-directory. You all know what it is. Okay, but OT is different. Now with IT, you get the old CIA triad. Everyone knows you follow this. Everything's secure. Confidentiality, integrity, availability, fixed. Okay? Now, when you get into OT, it's very different. When you get into OT, it all goes the wrong way around. Now, for OT, it's safety, availability, and integrity. Arguably, availability is a bit higher than safety, but we're not allowed to say that. So the way OT works is, you get really, really smart people that have a job to do. Someone comes in, he works in OT, and he makes mechanical instruments with analog systems that were built in the 80s, sometimes the 70s, in these nuclear sites. 6-ish, 7-ish nuclear sites. I do a lot of work up in the north, nuclear sites. And we get a lot of times where we meet these OT engineers that have been doing it for years. They're like 60 years old. And years ago, they were told, right, you've got to get that radioactive material out of that core, get it over here without anyone dying, put it in a lead bucket, and make sure it's safe. And that's what he's done. He's made sure he can do that, okay? He's spent a lot of time making a system. I've seen lead silos that float in water like canal boats that take things away and then robotic arms that pick them up and move them. It's pretty cool stuff, okay? But if I walk in and go, well, does it have a 16-character password? He's going to be like, what are you talking about? Of course it hasn't. It's a silo, Confidentiality doesn't matter. What matters is availability, safety. They're the things that matter the most. So let's talk about some OT buzzwords. SCADA. Okay? You've probably all kind of seen it with your eyes, but don't really know what it is. It's just the posh encapsulation of all the OT things. It's like the umbrella for all the next things I'm going to list for you. PLCs, RTUs, arguably Raspberry Pis with relays. Okay? You know how they work? You probably know how they work. HMIs, EWSs. HMI is usually a Windows XP machine that's sat on a big old machine that's doing something very important that nobody can touch or change, but don't worry, bro, it's air-gapped. Engineering workstations, typically more portable. They move around, they go out to the RTUs and PLCs that do ladder logic or fix stuff. They're always portable, they're a bit riskier, but they do their job. IACs, Industrial Automation Control System, also ICSs, Industrial Control Systems, and PESs, another encapsulation word for the SCADA systems that are in the grander scheme of things. So a lot of the diagrams you look at will sort of be IACs diagrams. And SIS, Safety Instrumented Systems. They have to be segregated. It's the law. And if they're not segregated, everybody gets told off. The O&R comes out of nowhere and gives you a fine. So we'll get into those a bit later on. CNI. So Like I said, I specialise in nuclear and water. You can see there's all the other CNI thingies up there, satellites, food, transportation, emergency services, all the stuff we don't want to go bang. Now, NCSC are all over this. They got the NIS directive and they renamed it a CAF. Now called the CAF 3.0, and they think it's absolutely fab. Okay, but it's really just the NIS directive, which is forked. Now, NIS 2's come out. There isn't a NIS 4.0, but sorry, there isn't a CAF 4.0, but there will be at some point. The I-100. So what NCSC did was they decided that all the questions they were getting from people in industry, people in water companies would go, I've got a load of leak detection devices, we don't really know how to secure them. There's not really any documentation on how we should secure them. Can you help? And they went, oh, absolutely. So they went out to the industry and said, have you got some experts, Airbus? Have you got some experts, Yorkshire Water? Have you got some experts? And we go, yeah, we guess so. We do it all the time. You're our experts now. Come on. So when anybody asks NCSC, have you got some experts? They go, oh, yeah, at least 100. At least. They form the I-100. And it's a good community of people because it means that instead of people that think they're experts making standards and NCSC publishing them, it means that the experts are formed internally in the actual CNI specific areas, and people that write the standards that end up on NCSC's website are people that have been doing it for years, and they're actually there. Okay, who knows what that is?
Chernobyl. Broken.
That's fancy. Some points, I like it. Chernobyl. So, when that was made, arguably, probably with the CIA triad, not the other one. Anyone that's seen the series or been on Wikipedia knows that it went bang when they were running a safety test. So, a lot of the stuff that we come into touch with, there's a really interesting bit of technology where if you're trying to grab some nuclear waste, if you get a lot of build-up of hydrogen, when hydrogen builds up too much, it's dying to blow up. And in the industry, we call it a pop. A really naive little name for something that could blow the walls off the building, but we call them a pop. Now, when you go for a grab, which is to grab the nuclear waste, if you get a build-up of hydrogen, you've got to fill it full of nitrogen and then vent it to atmosphere. Now, those mechanisms are mechanical. It's when the nitrogen comes in, physically closes the vent with a diaphragm, nitrogen comes in, purges out the hydrogen. If the nitrogen stops, the valve opens. Great. But has it got a 16-character password? No. And it never will. So, how do we do this these days in the old cybersecurity land? Recently, the ONR, Office of Nuclear Regulation, they're really on it. And they do a really good job helping the nuclear facilities sort out what they've got. But they're like every auditor. There's probably people in this room that's had an audit. Auditor comes in and he goes, let me see password policy. All right. Okay. Or your pen test policy, your cybersecurity policy, whatever. And he reads it. It says here, you pen test every device once a year. Yeah. He goes, okay, how many PLCs you got? 28,000. Show me pen test for every one of them. Oh, well, I don't really got one of those, and all of them, give you a sample. So yeah, you get a lot of that from the industry. Now, recently, they've been heading to a more unified set of standards. NIST is big. Everyone knows about NIST. NIST 2.0 is kind of out, and everybody loves it. It's difficult to map. Now, this standard up here, IEC 62443, bit of shit name. Could be better. But that standard has existed for a long time, and it was built for oil and gas. It was originally, you can't make an oil rig unless you follow this. And it's much less loose than 27001. 27001 is like, it better be encrypted. And you're like, what's it? How encrypted? You've got the options. How long should that password be? As long as you think. You're a florist, Make it up. Whereas 643 say things like, you may not transmit data outside of a zone. Crystal clear. But it's big. There's multiple standards. Maybe 11 or 12, probably more. And they all have little tags on them. So 62443 3-3 is the one that you'll bump into the most. Probably arguably the most interesting one because it has compensated controls that they recommend you should do, and less ambiguous. And on here you've got these levels, not 4. Now these levels always come from risk assessments. Now it's very easy. Everyone's seen a risk register where someone goes, how risky is that? And you go, easily a 2. And you're like, what does that even mean? What do you mean a 2? Well, what's the impact? Perhaps a 3. Where's that 3 come from? So what's the risk? 5, obviously. Now, these security levels, I've been on a path for 6443 and heading for a 6443 expert. We've got to hold all 4 certs in the same 3 years. I've got to nearly finish my 3rd. Hopefully I'll be an expert by next year. But for these levels, you have to do risk assessments. And what I've learned doing the 6443 training is your SL, your security level, is based on the output of your risk assessment. So let's say, for example, you've got a zone. And in that zone, you've got 2 modems. You're doing a risk assessment. It's the modem zone. You go in to the asset owner and you go, right, these modems, what do they do? And he's like, don't know. Nothing. I'll speak to the other modems over there. They're like, are they important? Don't know, not really. If they went off, would it be bad? Won't make any difference. What do they do? Well, nothing. So why are they on? Well, you can't turn them off. Why? They might do something, Conversations like this all the time. So I'm okay, is it a 1? And they're like, well, let's have a look at 1. It's protection against unintentional or accidental misuse. I mean, they're in a box. Okay. Are they on a network? No. So is that already protected? Yeah. Do they need to be? No. You end up with an SL0. You don't need to go and secure a device that was never built to even have a password on it in the first place. It's an SL0. But then you get the hydrogen system we we're just speaking about. Nitrogen through, hydrogen in. Let's say one day they were like, let's put it on the internet. And the risk officer steps in and goes, oh yeah, what are you doing? And he goes, how secure is that? Well, it should be really secure. Well, how much protection do we need? What would happen if somebody hacked in and just left that valve open and said it was fine? Here, you get a pop. Blow the wall off. Okay, so how secure does it need to be? As secure as possible. SL4 is protection against statewide attack. All of China, all of Russia, same time, protection. You might think that's hard, but not as air gapped, and not pretend air gapped, like proper air gapped. So, the next thing is the Purdue model. It was created in the 90s by Theodore J. Williams, and went to the Purdue University. See what he did there? Big name. So the Purdue model, this is something I never stumbled across in my IT life, but something I came across quite quickly once I got into my OT life. And it's structured at level 0 at the bottom, 1, 2, 3, all the way up to, technically it's only 4, but 5 has appeared as cloud has existed. So it's 1 to 5. Sorry, it's simply 0 to 5. Level 0, stuff that moves. Okay? If it's a pump, if it's an arm, if it's a ram, it's moving, it's down at level 0. Level 1, the stuff that controls the stuff that moves. Level 2, the stuff that controls the stuff that makes the stuff move. Okay, and it cascades up like that. Then you get your IDMZ up at the top. Arguably, that's where your internet should come in. Should never come in below. That's where you get trouble. And above, you've got HR, finance, all that jazz. Your enterprise zone. And then your cloud, usually your cloud processing. Here's a bit of a diagram. Very oversimplified. I don't like very complicated presentations. I like ones everyone gets. So, nice simple diagram. Same concept. The Purdue model isn't on there, but it's laid out the same. And the next is a zone and conduit model. You heard me speak about a zone already. Some modems in a zone. These are zones, and these are conduits. Now, the good thing about conduits is they're technically just an RJ45 plugged into a network, but at any time, you should be able to measure the traffic in there. I don't mean by latency. I mean, like, do a TCP dump, get a PCAP, have a look at it in Wireshark, and you should be able to say, oh, I have 9 IP addresses in here. And then when they order you and go, how much traffic should be going through that conduit and what should it be? And he goes, 9, and he goes, why they're 11? And he's like, I don't know. Well, there should be 9. So, zone and conduit's really useful. There's some rules. You're not allowed to go conduit side to side with zones. It's all got to be up and down. You're allowed conduits coming in and out, but you're not allowed to have a side by side. That's breaking the law. So, CyberRange. Time to plug. I don't get any commission for doing this, and I'm actually not plugging it because I've been forced to. It's dead cool, right? When I started Airbus, I was like, wow, we can do what? I was like, oh, that's cool, isn't it? So I got involved with CyberRange, and they were like, if you like it so much, you can kind of be in charge of it if you want. I was like, well, let's not jump the boat, you know? I was like, cool. All right, if I must. So CyberRange. Here's our fancy marketing slide, all 3D. You kick my ass if I didn't show this, so here it is. Just maps the NIST identify protect steps on the cover to all the functions CyberRange can do. I don't think it tells you much, but I'll tell you how it works at the end. Now, I said earlier, safety first, and that comes in a lot in OT. So, in IT, I'm sure we've all got horror stories about running Nessus. I've got some. Yeah. I think my funniest one ever, in fact, I was with Duncan. He's sat in the audience now. Hi, Duncan. Big wave. There he is. I was with Duncan. We were on a pen test, and I ran Nessus at something, and the printer just started printing stuff on. Bam, bam, bam. Some lovely lady came, excuse me, are you doing it in the printer? We had no idea, and I was like, oh, yeah. Yeah, that's so vulnerable, that printer. I'm showing how vulnerable it is. For God's sake. So, if we think a printer can do something like that, think of a device that used to receive an analog control, or just a 1 or a 0, that's been made digital, it's been converted, and its only job is to open a valve. And Nessus comes along and goes, you there, you there, you there, you there, you there, you there, you there. And before you know it, this thing wants to blow up, okay? So, you find a pen tester, you go, you're a good pen tester. Like, oh yeah, check team leader, me, mate. Double. In fan web app. You're like, didn't ask if you were double, but alright. Didn't ask. And you say, great, can you do pen tests? Like, oh yeah, anything. Anything. Your car, your house, whatever, pen test. Cool. Will you pen test this nuclear site? They're like, no. You pen test it? I'm like, you just said you could do anything. So, safety first. Now, it's quite often we see environments that are un-pen testable. You've got thousands of RTs, PLCs, a big SCADA network. The latency, the traffic going through it, you can't mess with the latency. Something's expecting a packet at a certain time. It has to get there in a certain time, otherwise a certain thing will open, and people could die. You could have instances where you're transporting something on a huge claw. It could be radioactive. It's up in a lead bucket, and if you go flying Nessus around, well, I'd drop it. The motor might go too fast. Get there before the door opens. There's loads of things that really, really could go wrong. So that's kind of where CyberRange has its shining features. As I said before, this fancy graphic doesn't say much. But this box over here, or better, this box, this is the CyberRange, okay? And it doesn't sound that fancy. It's an ESXi server. It's got VMware on it. It's got Docker on it. It's got loads of proprietary Airbus goodies on it. But the coolest thing is you can plug stuff into it. So you can go out to the customer site and go, right, what's the problem? They go, everyone else says we've got to have a pen test because we said we did them 6 years ago. We didn't. Okay, right. Well, can we pen test them? Like, no. And you go, all right, what do you want to do? Oh, use CyberRange. Give us some sample PLCs. Give me the configs. Give me your firewall configs. I'll virtualize the firewall. Exactly the same as it is in your network. I'll virtualize your whole network. We'll get that pen tester in. He can plug in and he can go bananas. And you go, all right, that sounds pretty cool. And then when the ONR come in and say, show us your pen test, you go, there you go. You go, it's covered in red. You go, yeah, but we did it. Okay, so there's your digital twin testing. This is a little screenshot. You'll see some of this line instead. A little screenshot of stuff that moves, stuff that controls, stuff that moves. All these have real bits of software in them that we're doing stuff. We tend to virtualize a lot of traffic, sometimes capture a PCAP and just rerun it in the network at the same devices and then loop back every 6 hours. So, this is the splash screen. Nothing fancy here. What we're going to do for this particular bit, do a bit of role playing. And I was going to pick someone at random from the audience, but I've seen my friend Wesley. And he's going to come on stage. Give him a round of applause. Here comes Wesley. Hello, Wesley. So, you'll need these flashcards for some of the attacks. Don't stand on the screen. Come on, out of the way.
All right.
Now, Wesley here is now the CISO for all the nuclear sites in the UK.
Really trustworthy.
Good job, Wes.
Thank you very much.
All the sites in the UK. And he's very good at his job, so he says. So we're going to go through a little tiny bit of CyberRange demo and then just a sort of hack example. It's not going to blow your socks off. It's very cool. Okay, so let's start. First thing you can do on CyberRange is you can pick an infrastructure, something you've made before. Here we go, an inf. Here's our nuclear demo. Here's a full OT deployment. You can drag it, drop it, it's going. Now, you're not just making a topology like Packet Tracer. They're all VMs. All those lines are network mounts. And all those networks on the left are running networks. You can click and out, click and out. And it deploys it with all this crazy amount of terabyte of RAM and all those CPUs and off it goes. I'll jump over to the particular demo I'm doing, which is the nuclear site. And we'll zoom in and we'll talk about the beginning, the initial access. So, initial access. What's the most common form of access for hackers? Somebody say it? Phishing. Lovely. Phishing. Straight in with the phishing. We'll just call them Remote User 2. Remote User 2. It's his second day. He's got an email from IT. He's handed over his password and he's given his VPN certificate away. He's done a really bad job. He was too scared to say anything. You know, you don't train him right. You get scared? So, Wesley, as the group CISO, can you explain to me what happened in this phishing incident?
Okay, well, staff morale is a little bit low. So we spent quite a bit of money on parties.
Oh.
Yeah. But not just that. Security is important to us. Yeah. So we spent a lot of money on Nexus licenses.
Oh, okay. Well, everyone knows they're expensive, eh? But if you've got a Nexus license, you're safe. Okay. So initial access was just a phishing attack. Nothing crazy. Now, you'd think from here we'd have to run all wiki commands and, start going to pen testing mode. But one of the cool, little plug here, one of the cool bits of Everset's product is if you can plan how to do a specific attack, you can automate it all in a button. And you can just say, here's the attacker, here's the target. You'll see some of this a bit later on. So, the next bit, Remote User 2. He's jumped in, and let's have a look at the config. So we can go in, open Remote Console. All these are VMs, they're all running. Go to the Remote Console, jump in, let's have a look at what network we've landed in. Through the VPN, nobody argue with me that 192.168.120 isn't a VPN address. Just accept it for the presentation. And here's the configuration of the network, okay? So it's gone straight through there, he's landed in the network. Now, you can do attacks by typing in the command. You don't have to go into the host, you can go execute system command. So we can type in system command here, with a nice long nmat, load of flags, ready for our attacks. Okay, hands up, quickly. Who here is confident they know what all those flags do?
Obviously.
Yep, okay, hands up. Yeah, minus RR stands for Rickrolled. Isn't the flag. Isn't the flag. So,
Mostly though.
yeah, we put your hand up. Put your hand up. So, yeah. And one of the reasons I put this into the presentation is CyberRange isn't really there to make you a pen tester. The real training concept is you go in, you work with the site owners, you rebuild their network, and you can do actual training exercises with new members of staff and go, let's turn this PLC off, and let's see how bad it is, and let's fix it. You can't just turn it back on. What are you going to do? Oh, we need backup config, we need this. Config's gone. What do you do? You train people. Okay, the next section, let's get rid of that nice big command, and move on to the next bit. So, our hacker's having to rummage around, and he wants to do a scan. We're not going to run the nmat, because we know that we don't want to get rolled again. So we use some of the automation. And here you've got Mount WannaCry USB. You've got ARP spoofing, brute forcing, DNS poisoning. All this stuff has been made by a French team who absolutely love it, and they never stop adding stuff to it. So we're on intense scan. And again, no typing required. We press intense scan. We go, he's our attacker. We're not using two. We go, what's your target? And we say, I don't know. The whole network that we've got access to? Yeah, cool. Click it. Join network. You're in. And we do some scanning. We press start. The scan fires off. Exciting stuff. And we fire off our nmat, as we all expect, with loads of really nice readable output. And after we've all had a good read of it, we realise that, there's a Sun SSH 1.1.5. And we've done what any good pen tester would do. We Googled it. We've gone on Google and we've identified that there's a buffer overflow. Of course it's got a CVSS of 10. That's like it was made for this demo. It's got a CVSS of 10 and we can get in there. Look, and it's in Metasploit. So I'll get a couple of commands. Cool. So us as notorious hackers, of course we're ready for this. We've written ourselves a wicked script. So we jump into our VM, we open a remote console, we type away, let's run our CVE attack. So execute, CVE, Metasploit, bang. Here we go. Hacking into the system like movies. SQL injecting, cross-site scripting, dumping the database. Movie magic. And now, the real command. Okay, run the actual command, we send the exploit over, that's the little firewall, it's like, sorry. Falls over, and ID, root. Wesley, can you explain to us why this has happened?
Don't worry about it, Fred. It's on the risk register.
It's on the risk register. Are there any comments on the risk register?
Well, there's a lovely low risk here.
Yeah,
it's the firewall. It's not internet facing.
Oh, well.
So you don't need to worry about it.
Okay.
It's fine. But we decided availability was more important, and we went to the pub instead. So we didn't need to do any
okay. Availability was more important, so they went to the pub instead. Okay. And when was that comment written, Wesley?
Just gonna check my notes.
Yeah.
2019.
2019. And what year is it now, Wesley?
2023.
Well, good to see, sir. He's really on top of these sorts of things.
Honestly, I'm all over it.
Yeah, okay.
I'm asking for a bonus.
Yeah. So the firewall's compromised. Okay, the firewall's compromised. We've got access to networks below what we previously had access to. Below anywhere that anyone should have access to. So let's carry on and look at the other networks we can see. So there's the network we've landed in, the 120, but there's two other networks that we didn't even know existed and technically shouldn't have ever seen. So let's back out of this and look at the way sort of CyberRange. Oh, little command here, got this bit. We flatten the network and make it a router. Okay, that little command just gets rid of all the rules and the firewall is now a router. So you can see everything, every bit of network. Here we have PLCs, engineering workstations, industrial control system cores, operator workstations. This is how the whole network's set up. You only really have access to the OWS. So we'll just pause here. This is a very common looking OT access point for an engineering workstation. Operator workstation. It's quite a simple one. You've got two pump banks, A and B. Pump bank C isn't in use unless 24 hours have passed. Okay? Now, every 24 hours it goes to B and C. So you can service A. If A fails, you switch C on. If C fails, switch across. It's backup. It's failover. Safety first, right? So you've got the failover, and you've got here the 24-hour switch. Now, Wesley, do you want to tell me about this 24-hour switch, please?
Check the old notes again. Wow, put into my notes. Application has strict input rules on what the user can press and when those parameters get changed.
Okay. So strict input rules. We've all seen those, right, on the web app? I'm sure it'd be alright if he's done that. Okay. Moving on. Memorise that little area. Let's jump into our nuclear area. Wow. There's a wow. There we go. Our nuclear area. We'll look at that later. Okay, too excited. And we've got our PLC. It's very common to find a virtualized S7 Siemens PLC. This thing is actually what's doing the work that the fancy GUI you just saw is touching. And you don't connect through that directly. You go through the firewall, and the strict firewall rules only let those two speak, which are now gone. So, next thing we can do is, we're notorious hackers, right? We've got a mission, so we're going to execute our mission. Remote user 2 is opening a remote console, and he's going to target the S7 PLC. Runs his Python script, targets it, and he's hit it. Bang. Now, that Python script saw a bit of plain text traffic travelling between the operator workstation and the PLC. It also had some embedded authentication in it, which we've just snappled, and then we send the packet across. We've looked at the parameters we can modify. What we've done now is we've switched the switch timer to every second. So every second, those pumps go A, B, B, C, A, B, B, C, A, B, B, C, A, B, and it gets hot, okay? Now, it gets really hot. Well, don't worry. The web app would stop you from pressing that. Now, Wesley.
It shouldn't have happened.
It shouldn't have happened. And why was it all plain text?
Well, according to this, legacy hardware doesn't physically support encryption due to its age. It's behind a firewall, though.
It's behind the firewall, though, the one we compromised that hadn't been patched for years. So, nice and safe. Nice and safe. Okay, so, this has happened. It's been switched to every second, and that's going to cause bad things to happen. Our pump house is going to get hot. Let's switch over to our pump house and see what's happening. Well done, Wesley. Half of Yorkshire's off now.
I still think I can get that bonus.
I hope you're pleased with yourself. We've wiped out half the nuclear core. And while that's down, it's costing us a whole lot of money. See the top, this metric. You can see the top, this metric is accumulating. Pretend it's in pounds. The French did it in dollars for me, which is very kind of you. Pretend it's in pounds. You see this metric is accumulating, going up and up. We've lost our power. Our turbines have stopped. Our reactor temps going up and going down. Our cooling tower's unhappy, and the control rod's 0%. Very, very unhappy indeed. Now, how has this happened? Well, it looks like we've got a lot of poor controls, lack of compliance, lack of training, lack of patching. I'm sure you'll blame it on lack of funding.
Well, the staff morale is high, though.
Staff morale is high. Staff morale is high.
We'll cover this up.
Staff morale is high.
Very on LinkedIn, look for another job, I think.
Yeah, I'd probably recommend it. So, as we've all seen here, This wasn't quite as bad as Chernobyl. We didn't get a pop. We didn't blow a hole in the side of the place. But it's difficult for nuclear sites to come to compliance because there's a lot of legacy kit. And they're strangled by budget restraints. And if you get somebody that's known a system for 40 years and he's like retiring now, it's 40 years of knowledge. It's difficult to write down. Okay, so that was my presentation. I'm going to leave that render on screen because it's fun. Wesley, thank you very much for being on stage. Round of applause for Wesley. And I'll not switch to a slide that says questions. I'll just vocally say, has anyone got any questions? It doesn't have to be quite about this demo. It can be about career, how I got there, my dog, whatever. So any questions going out?
This was extreme deja vu.
You've blown up a site?
Yeah.
It was it?
I was doing a pen testing exam on OT in February. First in map, everything linked itself. That's the end exam.
Yeah. Yeah, you can't map things. You'd be lucky to do an ARP scan. Everyone's like, I'm not responding to him. So yeah, it's pretty difficult stuff. I mean, a lot of the times when our consultants go in, we have a pen testing team in Germany that doesn't test OT right now. But we work a lot with the nuclear opcos, operating companies. There's different sectors of them, and they tend to get pen testers in. And a lot of the time, you get pen testers like, easy. I can do that. Easy peasy. And then they get in and you're like, show me a pen test. And they're like, yeah, it's not very good. You can have a look at it. Like, what did you test? Nothing. So a lot of the time now, we're getting people that are coming to us and they scope the job with our CyberRange in. They don't even bother trying to scope the job with the actual range, with the actual VLAN and the devices. One of the first things to say is like, yeah, what's the CyberRange? Let's plug everything into that and we'll just pen test that. So it works really well. A lot of the time you get secret nuclear information. So the good thing about the box on wheels is you can take it there. You do all your testing and then you wipe it. So it's pretty cool.
Because once the panic sets in, once everything stops, it's, there's no undo switch to...
No. Like I say, some of the mechanical controls I talked about for the hydrogen and nitrogen, some of the mechanical failovers are designed never to be restored. Like, if they can save a life and absolutely buckle and destroy themselves, that's what I'm going to do. And the systems that are built are cool. The guys that build them don't care about confidentiality. Care about availability and safety. I've got loads of them. It's closest to me.
What sort of weird and wonderful devices can you emulate in your site? Because let's face it, there's a lot more than the Siemens PLC.
Yeah.
And some of the things nobody's ever.
Yeah, anything that's got RJ45 basically. Because it's got RJ45 on the back, you can plug it into it. We then map the connection to it. So if you've got a device that you would normally plug into your machine and dial into its GUI, you can map that into CyberRange and render it inside it. You can also mount gateways and fetch things. We have we have a bundle store, an app store. So like when Log4j came out, you got an automated bundle. You just had to connect to the store. Yeah, you can mount any physical device as long as it's got RJ45.
Can you simulate?
Anything, it's VMware and Docker.
It is, but that's, if you've got something that needs like a 20-year-old kernel or something, you can't just download the source code for it.
Well, if you're not trying out,
yeah, okay. Basically,
I didn't make this. I didn't make CyberRange. Okay, I've worked at Airbus for a year, but I've seen them emulate a lot of stuff, a lot of legacy stuff. But I couldn't tell you. I haven't got a good answer for you, if I'm honest. Someone on the back. I don't know. You. Back up you.
Yeah, that's kind of how I extended on this question. With any education that you encountered where you had to sort of go on to the actual instruction itself, CyberRange didn't quite fit.
We've had some bad times trying to transfer some analog inputs to digital ones. Some of them have gone fine. Some of them just don't play ball at all. So we end up trying to find a way to emulate the way it behaves to validate the way the pen test went. You can say, the pen test is an actual thing, but here's what the code says and the ladder logic says is what it would have done if it fell over. You? Anyone else? No? Hands gone down now?
I was just going to ask, sort of in the same vein, I guess, as what everyone else is saying. Obviously, if you're going on site and trying to simulate what they've got there, you've already said that there's often an issue if they don't really know what things do.
Yeah.
So how do you simulate that? How do you work that out?
Well, I mean, it's not quite that bad. It's not like, what's that like, bro? You get every now and again.
It does happen.
It does happen. You do get a nose, but if they paid all the money to get the CyberRange in, there's a team of guys that know the network that will show you a diagram, and you'll pull all the right configs off together, and then you'll build it all together.
Sorry, for what?
What? Config.
What's D word, is that?
Diagram.
Could you explain?
Yeah, if you stay a bit longer, I'll teach you after this. I'll teach you after this. Okay, next question.
Me?
Yes, you.
So, I've also had a lot of deja vu during this talk, but not from the OT side, but in the general IT security end, I've had the VPN system that the client refuses to update because of availability. I've had the system where they go, oh no, it's fine, it validates the input. But it turns out, no, it just does it with one end, not the other. So what I'm curious about is, what do you think the OT side can learn from the IT in terms of security, and the IT side can learn from the OT?
Some question, you don't want to answer it. No, I'm going to try. Okay, so I find the OT side, a lot of the time, you've not got real risky bits of data flowing around. It's normally stuff saying, are you on? And it goes, yeah. You know, it's not very simple data. So a lot of the controls that are all the way down in OT, confidentially, it doesn't matter. The IT realm, you've got loads flying around, obviously. You've got loads of PII, sensitive information, emails with this stuff. The biggest thing is keeping them segregated. They are completely different beasts. You can't put 2FA. You can't put a 3 username password lockout on a core that's going to blow up. You know? John, turn it off. Oh, no. It's going to crack. It's going to crack. Why did the site go bang? He forgot his password. So I struggle to give a very good answer for that, to be honest. There really are different things. So that's my sort of answer. Sorry, it's not great.
As well as pen testing on OT networks, can it be used for maybe sort of simulating and creating a honeypot or deploy that network?
Yeah, so there's some slides that I haven't got on here, but mark it anyway. Kick my head in for not having. But it's not just for OT, this. We use it as like a training platform as well. So we have training platforms where you have different work zones, and you can set up a networking work zone 1, a networking work zone 2. They can red team, they can blue team, and you can watch. You know, and like, how are you doing? How are you doing? You know, it has all the snapshot functionality in it, and you can store in tables, and you can see you can make a topology, and you stop. And then you want it in, you just right click and clone work zone, pops in another one. So it does have a gateway mountable to every work zone. You configure a gateway, you say which physical port it's mounted to, and then that gateway has got the internet, and you just connect this to this. So in theory, absolutely. We've never really done it. No one's really asked us because it's in a nuclear site. So can you just get the internet in a job? No. Absolutely not. Yeah, they usually, CyberRange usually offline.
You just made a statement about getting the internet on the nuclear site.
Yeah.
Documentation management of systems and things on that sort of environment might benefit from having access to internet repositories for all of the data and information and business information management systems. So how would you use this as a tool to provide a safe way to get internet into the site? Or alternatively, what recommendations it would output that would say, well, these are the things that are going to make a difference to make you more secure. Obviously, segmentation is one, but what else?
Yeah, I mean, when we deploy them, we speak for a long time with the customer on what's your problem, what do you want to train them on, how do you want to do it, where do you want to put it, how do you want to do it, and then we'll give recommendations of where to put it, like internet/31, put it on there and fill it with IPs, so nothing else can get on there, and make sure it's in some VLAN and make sure it's ported to a different external IP address that you can. The documentation side, in the CyberRange, there is a documentation button. It's piled full of goodies. So when we do stuff for customers, it's quite often they'll put them on the CyberRange during the training activities. They've got documentation, this particular exercise, which no one has a name, and they'll read through how to do the exercise and how to do it properly, the best way to do it. You know? Questions about?
So the side, it might not be the side of the equation that you have more experience with, but when it comes to sort of instant response of these engagements, you know, like a endpoint in your example where the human machine interfaces, they're just Windows boxes that are relatively simple. But how would you go about sort of verifying the integrity of these deeper control systems and what artifacts are there? And more linked to this.
Yes, there is big.
Possible to use as a sort of
There's big honest discussion about fidelity with VMs. It's all great getting a VM, dragging it over and restoring it, but like, is the fidelity identical? Is it really going to be over the same way? We always hide behind the same banner. It's a sample-based exercise. If you want to test this in this way, you can't test it in your environment. You're not going to go and make it again to test it. It's kind of the best middle ground that we can do. Yeah, there's always big discussions on fidelity because sometimes we'll say, send us your VM, and we go, well, you've got a 2 terabyte USB stick. And I'm like, what? Why is it so big? It's not big enough. And you're like, I don't want that. And then you have to go in and be like, why have you got 2 terabytes? What's on there? So we get a VM, we have to redeploy it their side, and then remove a terabyte of logs. We really need all them right now doing, and you have to trim it down as best you can to get them on CyberRange we don't fit.
Considering some of the security classification of configs and things that would come out of here, where you said about just wiping the CyberRange down after it had finished up with, is that always enough? Do you have to swap the drives?
Right, usually, yeah. They normally say you can only put our VMs in a specific drive, and we'll make a specific partition for that. And then when it's done, disassemble it. They dispose of it via their disposal policy.
So it's a hard swap rather than a...
Yeah, usually they take the RAM as well, which I think is a bit excessive. All right. Any other questions? Okay, great. Well, one more.
Have you replayed Stuxnet through it?
I haven't, but I'm sure the French have. Okay, on that bombshell, and this talk, thank you everyone for coming. And,